Hello everyone, myself Ajaykumar M, Assistant Professor in the Department of Mathematics. Now in the today's session, now I am going to discuss the next method, the Runge-Kutta method of fourth order. Okay, the 2 to 3 sessions, now already all of you know that now how to solve the first order and first degree ordinary differential equation with the help of Taylor series method. Now the next one with the help of modified Euler's method here. Okay, now the next method, the Runge-Kutta method of fourth order. Here we consider in general, the differential equation is in the form of dy by dx is equal to the f of x comma y with initial condition y of x naught is equal to the y naught. Okay, now we can estimate yn value at the particularly now the point xn is equal to the x naught plus n into the h. Okay, the h here step size with the help of the RK method. Okay, short form now we can call in terms of the Runge-Kutta method of the fourth order can be called in terms of RK method. Okay, here RK. Okay, right. Now here we consider the first one k1 h into f of x naught comma y naught. The function now we can specify in terms of now the k2 here h into f of x naught plus h by 2 y naught plus k1 by 2. Now the next one k3 here h f of x naught plus h by 2 y naught plus k2 by 2. Now the another one k4 h f of x naught plus h y naught plus k3. Now we can specify here. Okay, using the values of k1, k2, k3, k4, now we can estimate the corresponding the values here. Okay, now we can specify in terms of y of x naught plus h. Okay, now what about your s? It's equal to the y1 y naught plus 1 by 6 k1 plus 2 into the k2 plus k3 plus k4. Okay, is it clear? Okay, now here the another method to solve the differential equation. Here we consider in terms of the first order and first degree ordinary differential equation dy by dx is equal to the f of x comma y with the initial condition y of x naught is equal to the y naught. Now we can estimate the yn value at the particular point xn is equal to the x naught plus nh where h be the step size. Okay, first we have to find out k1 h into the f of x naught comma y naught, k2 now h into the f of x naught plus h by 2 comma y naught plus k1 by 2. Okay, here already k1 value available. Now here we can using the k1 value now we can simplify here. Now k3 h f of x naught plus h by 2 y naught plus k2 by 2. Now k4 h into the f of x naught plus h. Okay, the important observation here x naught plus h, not for the h by 2 here, important, y naught plus k3 here. Okay, now the k3 means here, right, here k4 h into the f of x naught plus h y naught plus k3. Okay, here the important observation. Okay, now what about here s? Now we can estimate y1 value at the particular point x1 here. Okay, now y of x naught plus h is equal to the y1. Okay, now y naught plus 1 by 6 k1 plus 2 into the k2 plus k3 plus k4 here. Okay, the one important, the formula expansion for the RK method, using this formula expansion, okay, now we can estimate the y1 value here. Okay, next we can discuss the some set of examples on RK method here, right? Okay, right. Now here we discuss the first example, the RK method of fourth order. Using RK method, find y of 0.2 for the given function dy by dx. Now it's equal to the x plus y. Here h here 0.2, y of 0 is equal to the 1 here. Okay, now the answer. Okay. Now the first example here, given function dy by dx x plus y f of x comma y. Now we can assign the function. Now x naught here 0, y naught 1 given, h value 0.2 here. Now first we have to find out the k1 value. Okay, the k1 value means here h f of x naught comma y naught here. Now h value here 0.2, f of the x naught value 0, y naught value 1, the function of 0 comma 1 here. Now the k1 0.2 into the function already we have x plus y. Okay, now 0 plus y, 0 plus 1, now we can consider in terms of it's equal to the, after simplifying we get 0.2. Now the k2 here is h into the f of x naught plus h by 2 comma y naught plus k1 by 2. Okay, already we have the k1 data, now we are substitute here, now we can simplify. Okay, here k2 0.2 f of, okay, x naught value here 0, now the next one 0 plus h value 0.2 by 2 comma y naught value 1 plus k1 by 2. Okay, k1 by 2 means here previous k1 value 0.2 available, that's why here 0.2 by 2. Now next one k2 0.2 into f of the 0.1 comma 1.1, now we can specify here. Okay, the k2 here 0.2 into now the 0.1 plus 1.1, now we get 0.24 here. Okay, likewise now the next one we can find out the k3 here. Okay, now the k3 h into the f of x naught plus h by 2 y naught plus k2 by 2 here. Okay, now the k3 here 0.2 into f of x naught plus h by 2, already the previous result available same 0.1, now you can replace here 0.1. Now the next one y naught value 1, k2 value previous value 0.24, denominator 2 here, right. Now the k3 here 0.2 into f of 0.1 comma 1.12. Now after the substitution, now simplifying, now we get k3 here 0.244. Now the next one k4. Okay, the k4 here h f of x naught plus h comma y naught plus k3 here. Okay, k4 here h value 0.2. Okay, now we can consider in terms of, now the into f of the x naught plus h. Okay, x naught value 0, h value 0.2, that's why I directly taken in terms of 0.2. Next y naught plus k3. Okay, now y naught plus k3 means here y naught value 1, now k3 value 0.244, now after the simplification 1.244, now substitute in the function, now we get 0.2881. Okay, the function available x plus y, that's why here 0.2 plus 1.244 into 0.2 we get 0.2881 here. Okay, now already we have, once we find out the k1, k2, k3, k4, now the next one now we can specify here. Okay, next one now we can denote in terms of in such a way that, okay, y1 value we can estimate here. Okay, y naught plus 1 by 6 k1 into the k1 plus 2 into the k2 plus k3 plus k4 here. Okay, y1 here y naught value 1, 1 by 6 k1 value 0.2, 2 into the k2 here 0.24, k3 here 0.244 plus k4 0.2881 here. Okay, with the help of calculator now we can simplify y of x naught plus h is nothing but y1. Okay, now y of 0.2 at the particular point, okay, the x1 0.2, okay, y of 0.2, now we can estimate 1.2428 here. Okay, now one of the important, the observation in such a way that, suppose we have the first order and first degree ordinary differential equation likewise. Okay, with the help of RK method, now we can simplify, we can estimate the corresponding y1 value at the particular point of x1 here. Okay, now in the second example, as given dy by dx is equal to the y minus x, denominator y plus x, the given function, right. X naught is equal to the 0, the initial value, y naught is equal to the 1, okay, h is equal to the 0.2. Right, first we have to find out the k1 value. Okay, the k1 value means here h f of x naught comma y naught, h value 0.2 into f of 0 comma 1 here is 0.2 into 1 minus 0 denominator 1 plus 0, because the given function now we can take in terms of the f of x comma y. Now we can assign here. Okay, now after simplifying we get k1 is equal to the 0.2 here. Now the next one, k2 h f of x naught plus h by 2 comma y naught plus k1 by 2 here. Okay, now k2 0.2 into f of 0 plus 0.2 by 2 here comma 1 plus 0.2 by 2. Now we can denote in terms of s. Okay, now the k2 is equal to the 0.2. Now here we can specify in terms of into f of 0.1 comma 1.1 here. Okay, now what about the k2 here? Now we can denote in terms of the 0.2 into 1.1 minus 0.1, denominator 1.1 plus 0.1, because here x value along with the y value, the function now we can assign here. Okay, now using calculator now we can simplify. The k2 is equal to the 0.1667. Now we can denote. Okay, right. Now the k3 here is h f of x naught plus h by 2, right, comma y naught plus k2 by 2 here. Okay, right. K3 here 0.2 into f of the 0.1. Already we have the previous data x naught plus h by 2. The directly now we can write down 0.1. Okay, now the next one, 1 plus 0.1667 by 2, because here k2 value 0.1667, denominator 2 here. Okay, now using calculator after simplifying, applying the function, now we get k3 here 0.1662 here. Now the next one, okay, now here k4 h f of x naught plus h comma y naught plus k3 here. Okay, k4 here 0.2 into f of x naught plus h. Okay, x naught value 0, h 0.2, that's why here 0.2 directly, comma y naught 1 plus k3 here 0.1662, 1.1662 now we can denote here. Okay, now after the substitution in the function, now the y minus x by y plus x form, now here x value along with the y value, now we get k4 value 0.1414 here. Okay, now next we can consider in terms of y1 is equal to the s, y0 plus 1 by 6, k1 plus 2, k2 plus k3, now plus k4 here as y1 is equal to the y0. Okay, here we can consider in terms of the y0 1, next 1 by 6 now we can consider in terms of, okay, right, k1 0.2, next 2 into the k2 here 0.1667, now the next one k3 here 0.1662 plus k4 0.1414 here. Okay, now using calculator now simplify, we get y1 1.1679 here. Okay, otherwise we can also represent in terms of y of 0.2 is equal to the 1.1679 here. Okay, now the important observation, okay, at the particular point h is equal to the 0.2. Okay, now we can specify in terms of the particularly here, now x1 can be specified, x1 is equal to the x naught plus 1 into the h. Okay, right, that's why here x naught 0, h value 0.2, x1 is equal to the, now we can denote 0.2 here. Okay, at the particular point of x1 0.2, now we can estimate the y value 1.1679. Okay, now that will be the important thing here. Okay, right, now the next example, now we can consider in terms of, okay, now Okay, right. Okay, here is now the next example. Okay, the given example here, the dy by dx is equal to the 3 e power x plus 2y, y of 0 is equal to the 0, h is equal to the 0.1 here. Okay, to find y of 0.1 here. Okay, by the RK method. Okay, given dy by dx 3 e power x plus 2y. Now the next one it's equal to the f of x comma y. Now we can assign the function f of x comma y here, right? Here x naught 0 given data, y naught 0, h value 0.1. Now x1 is equal to the x naught plus h. Okay, 1 into the h. Okay, now we can specify in terms of x naught 0, h value 0.1. That's why here x1 0.1. Okay, we have to estimate the y1 value at the particular point x1 here. Now that will be the important thing. Now the k1 h into the f of x naught comma y naught. Okay, right, h value 0.1. Now the next one f of, okay, now we can consider in terms of the x naught value 0, y naught value 0, f of 0 comma 0. Okay, it's equal to the 0.1, right? Okay, 3 into the e power 0. Okay, now x naught value is 0 here, that's where e power 0 plus 2 into the function available, y naught we can replace 0 here. Okay, after the simplification, e power 0 1 into the 3, okay, 3 into the 0.1, 0.3, rest of the remaining 0 here. Now we can exclude k1 0.3 here. Now the next one, k2 here, h into the f of x naught plus h by 2, comma y naught plus k1 by 2. Okay, now right, okay, the k2 is equal to the 0.1 into f of the x naught plus h by 2, okay, 0 plus 0.1 by 2. Okay, now the next one, now we can consider in terms of the y naught plus k1 by 2. Okay, y naught plus k1 by 2 means here, now we can specify in terms of the next considering here 0 plus 0.3 by 2 here. Okay, now the next one, k2 is equal to the 0.1 into the f of, simplify 0.1 by 2, 0.05. Now the 0.3 by 2 here, 0.15, now we can denote. Okay, next one, k2 here, 0.1 into, now apply in the function, okay, 3, right, e power s in place of x value, okay, 0.05, okay, right, plus 2 into the in place of y, now we can assign 0.15. Okay, using calculator, now we can simplify, we get k2 is equal to the 0.3454 here. Okay, now the next one, k3 here. Okay, k3 means here h, f of x naught plus h by 2 comma y naught plus k2 by 2 here. Okay, right, k3 here, h value 0.1, right, f of x naught plus h by 2, the previous data already simplified. Okay, now 0.05, the same now we can assign. Now the next one, y naught 0, k2 by 2, k2 here 0.3454, now substitute by 2. Okay, after the simplification, substitute in the function. Now after simplifying, we get the corresponding here as k3 here 0.3499. Okay, now the next one, k4, h, f of x naught plus h, y naught plus k3 here, right, k4 here 0.1. Now the next one, the function f of x naught plus h, okay, x naught 0, h value 0.1, that's why here 0.1, y naught plus k3, okay, right, now the y naught 0, k3 value 0.3499, now directly we can write down 0.3499. Next, now substitute in the function here. Okay, now what about the function, now we can consider in terms of k4, okay, 0.1, now the into 3 into the e power 0.1 s plus 2 into the 0.3499. With the help of calculator, now I can simplify, we get the k4 0.4015 here. Now the next one, y1 to estimate here. Okay, y naught plus 1 by 6, k1 plus 2 k2 plus k3. Now the plus k4 here, now we can consider in terms of, next y1 is equal to the, okay, next we can specify in terms of the y1, now we can consider in terms of y of 0.1, 0, y naught value 1 by 6, 0.3 plus 2 into the 0.3454 plus 0.3499, okay, the multiple of 2 here is plus 0.4015 here. Okay, with the help of calculator now I can simplify. Y1 is equal to the y of 0.1, we get 0.3487 here. Okay, now the one of the important observation, okay, for the given differential equation, okay, the h value 0.1, now we can estimate the y1 value at the particular point x1. Now that will be the important thing here. Okay, thank you for watching the video.